This video will cover the topics relations and functions and a little bit of what goes along with that. Okay, we're going to compare and contrast relations and functions, what makes a relation a function, what makes a relation not be a function. Okay, we're going to represent those relations and functions in multiple ways. We're going to determine the domain and the range of both of those. Okay, so first things first, we got some vocabulary here. What is a relation? A relation is a collection of ordered pairs from two sets. In Algebra 1, generally we're going to say that the first set is going to be our x values, that's going to be the input, and the output of that relation will be the set of y values. Okay? A function is a specific type of relation in which each input has one and only one output. Okay? The domain is going to be the set of all input values for a relation or function, and the range is going to be the set of all output values for a relation or function. Okay, feel free to pause the video here and write those definitions down if you need to. Okay, like we said, relations can be represented in multiple ways. One of the ways is with a table, like a table of values. Another way is with a graph, and a third way is with a mapping diagram. Okay, so let's look at an example problem here. In a raffle run by the local booster club, prizes were given in the following order. The first ticket drawn won $100, second ticket drawn won $50, and so on down the line, okay? So this is a relation. We've got input values, which is the number that your ticket is drawn, and we've got output values, which is the prize money, okay? So we want to write these, each of these scenarios as an ordered pair. So the first ticket drawn would be written as 1, 100. The input is 1, the output is 100, okay? Second ticket corresponds with $50, so that's the ordered pair, 2, 50, 3, 25 for the third ticket, 4, 10 for the fourth ticket, and 5, 5 for the fifth ticket. Okay? If we want to represent that same data using a table of values, okay, we would just have our input values in this first column, the left-hand column for ticket number, and the right-hand column would be our output values, our prize money. Okay? And finally, we want to represent those with a graph. Not finally, next to last, we want to represent those values with a graph. So the first ticket here that corresponds with 1, the input value is always going to go on our x-axis. The output value is going to be our y variable, our y-axis here. Notice how we've labeled both axes. You need to have labels for every graph. Okay. The first ordered pair was 1, 100. So you want to make sure your scale is consistent on both axes. All right. However you want to set up your scale is fine as long as you're consistent. Okay. Second ticket corresponds with 50. Third ticket corresponds with 25. Fourth ticket corresponds with 10. And the fifth ticket corresponds with 5. Notice that we don't need to connect these dots. You know, this location here would be 1.5. You can't be the 1.5 ticket. You know, you're either the first ticket or the second ticket. So if we were to connect these dots, you're assuming then that 1.5 has an output, and it doesn't in this case. Okay? Finally, now, we want to use a mapping diagram. So we've got all of our input values here. We have all of our output values here, and we want to draw arrows for the corresponding pieces there. So 1 corresponds to 100. Okay, so we've got that ordered pair mapped. 2 corresponds with 50. 3 corresponds with 25. 4 corresponds with 10. And 5 corresponds with 5. Okay, so this is how you would complete a mapping diagram. Notice the input go in order from smallest to largest. Same with the output. We need to have those in order from smallest to largest. Okay. So using the information from problem 1 is the relation a function. Okay. So remember, we defined a function as a relation where each input has only one output. Okay. Notice each of these input values corresponds to only one output value. There's not an arrow going from 1 to 100 and another arrow going from 1 to another value. If you were the first ticket drawn, you win $100. Okay. Nothing else goes along with that. That's the same for each of these input values. So this would be a function. Okay. All right. What is the domain? Well, the domain is the set of all input values, so that would be this set right here. Okay, we're going to list each of these as part of the set. So we're going to use curly braces to distinguish our set. We're going to go in order from smallest to largest, just like we did in our mapping diagram here. Okay, so the domain for this relation, for this function, is 1, 2, 3, 4, and 5. To determine the range, we're going to look at the set of output values here. And again, just like with the domain, we want to go in order from smallest to largest, okay? So the range for this function would be 5, 10, 25, 50, and 100, okay? All right, so let's look at number 4. We've got 3 different relations here. We've got a graph of one relation, we've got a table of values for a second relation, and we got a mapping diagram for a third relation. Now we want to determine if each of these relations are functions, and then we're going to list the domain and range for each of the 3, okay? So in part A here, we've got a graph. So these 2 ordered pairs both have the same x value. X here is -3. So the input value -3, okay, remember x is the input value. The input value -3 has an output of 4 and an output of 6. Okay, it doesn't matter what's going on with the other points because here at x equals -3, we've got 2 different y values. So one input has multiple outputs. That means this is not a function, okay? Now, the domain is going to be the input values, the x values. So we've got -3 is here. This point has an input value or an x coordinate of -1. This ordered pair, this point has an x value of 1, +4 here, and +5 here. So the domain would be -3, -1, +1, +4, and +5, okay? The range is the y values, the y coordinates. So we'll go in order from bottom to top. So this y coordinate is 0. As we move up, the next point is here at 3. So we've got 0 and 3. Next one is going to be at 4, then 5, then 6 here, and finally the largest y value is 7. So 0, 3, 4, 5, 6, and 7. So that should be my range. Okay? Let's look at the table of values here. Okay, is it a function? This input, and so on down the list. Each input has only the one output. Okay? That means this is a function. It's actually a special kind of function that we're going to learn in the very near future. All right? The domain is going to be this list of x values. Remember, x is the input is the domain. So those 3 always correspond. So we're just going to put those in order from -3 up to +3, all those integers. Okay. The range is going to be the y values. Remember, in order from smallest to largest, so 0, then 1, then 4, then 9, okay? Notice we don't have to list the 9 twice, or the 4, or the 1 twice. As long as they're in our list here, they've already been accounted for in the domain. Excuse me, the range in this case. All right? And finally, the mapping diagram here. It is not a function. If you'll notice, the input value 2 here has 2 different output values. Same thing with the input 4. 4 has an output of 0, but 4 also has an output of 5. Okay? So this one's not going to be a function. The domain is the list here, 1, 2, and 4. We only have to list the 2 and the 4 the one time. And finally, the range is -5, 0, and 5. Okay? So that's everything you need to know for now about relations and functions.